I recently posted a short video showing the lighting on my stairs and asked you to let me know if you wanted a more in-depth look at the setup, and you most certainly did. So here it is. I plan to walk you through the evolution of this setup, because while it was easy in the end, I shot myself in the foot along the way. So stick around until the end, as there are some important lessons that could help you out with your installs. I started off some time ago by putting up this coving and throwing a cheap light strip up there to see how it would look. And it looked good, but could have been better. So when I got into addressable LEDs, I threw some offcuts of RGB 30 LED per meter strips up there with one of our controllers, which looked good and worked even better. But there was still room for improvement, as I had cables running down the wall and not quite enough power from this USB socket to run them at full brightness. So I recently got around to upgrading both the power supply and the strip itself to an RGBW strip with more than enough juice to power the whole lot and double the LED density, and it now looks way better and brighter. And I also managed to hide that power supply in my study and drill straight through the wall to get the power wiring completely hidden. The next challenge was the stairs. I'd been thinking about adding more LED strip to the stairs since I went for addressable LEDs, because then I could have it light up with this amazing linear effect. And even better, I'd theorized and proved a way of having it light up in the direction that you were traveling along the stairs by checking this zone at the bottom of the stairs on my Aqara FP2 for presence, then lighting the strip upwards if someone was in that zone when motion was triggered at the top of the stairs, and the other way if not, which works really well 9 times out of 10. So once I had all of this working, the challenge was to figure out how to neatly power this setup. The trick wound up being to make it a separate strip and controller to the landing, as there was no way I was going to get power and data across to the stairs neatly. I eventually decided that I would light up the left-hand side, partly because I already had lights on the other side, and partly because I had an offcut of the same RGBW strip as the landing strip, which would fit this side perfectly. Plus I could hide away the power supply in the cupboard underneath the stairs pretty easily, with only a short wire going around here to power the end of the strip. The final piece of the puzzle was to get everything timed just right to look as though it's one single strip. Whilst these are named WLED controllers, they can of course run any software that this ESP32S3 chip can, and my dad happens to have written his own which does what I wanted more easily than WLED, so I used his. But you could get the same effect in WLED using the percent effect, with the intensity slider I think. On my dad's software I simply set up 2 virtual strips on each controller, all configured to transition over the course of 1 second. But on the second of the virtual strips on each controller, the top LED is set to the final LED, which results in it going the other way for the bar graph effect that I'm using. This is like setting reverse direction in WLED if you're familiar with that. Then I use the method I mentioned earlier to work out which way the person is travelling along the stairs, and then turn on the appropriate direction with a 1 second delay between each action in the correct order. And the results ended up being better than I ever expected. However, it wasn't all smooth sailing. And I want to talk about the challenges I faced with this particular strip down the stairs, because I had some problems which I absolutely could have avoided, and could save you making the same mistakes that I did. To give you some context, I opted to put the controller at the bottom end of the staircase, and power it from the top, to reduce the number of connections all being at one end. And since our controllers can be powered from any common strip voltage, this works great. Unless you have too much voltage drop, or a noisy connection along the way. Now, when I said earlier that I had the perfect length offcut, I lied. I actually had 2 offcuts, which combined to make the perfect length. The trouble was, when I finally decided to mount this strip, in my infinite wisdom, I did so at like 9 PM on a school night, which put me on a clock. So, naturally I cut a couple of corners, like using these crimp connectors to connect the controller to the strip. And even worse, I used one of these to connect the 2 sections of strip together. Now, of these 2 connectors, these ones are okay if you connect them correctly, but these ones are typically garbage, and I knew it. I should have waited until morning to solder the strips together properly, but I jammed them into this and went to go and see how it looked. I lined it up down the stairs, saw how cool it was looking so far, and got overeager to stick it all in place and call it done. Big mistake. The following day, when they were configured to turn on much brighter, the controller would crash every time they lit up, because the current draw caused too much voltage drop to run the controller at the other end, dropping below 4 volts. At this point, I was powering it from USB, as I'd hoped it would be a short enough run to do that, but clearly not. So I wired it to a proper power supply instead, and then everything was working fine. Then a really weird thing happened. That evening, it started crashing again when it lit up, even though I had been running it fine all day on maximum brightness pure white. The issue turned out to be that as the day goes on, my functional lighting uses a progressively warmer colour. Now, since this setup is RGBW, the pure white was only using one diode within each LED to output white at roughly 0.1 watts per LED, as does each other colour. So what happened was, as the desired colour got warmer, it started to introduce the red diode, drawing more current, dropping the voltage at the end of the strip, where the controller was. And this is definitely something to be aware of, as most guides on calculating power draw of addressable LEDs suggest working out the current draw for the total number of LEDs on full white, because for RGB diodes that means they're all on at maximum brightness to create something resembling white. But RGBW strips are much better for functional lighting because they have that extra dedicated white diode, which uses as much power as any of the other diodes individually to create a much more pure white colour whilst also using less power. So to summarise, on an RGB strip, changing the colour to be warmer uses less power because it lowers the green and blue diode brightnesses. But on an RGBW strip, it can increase the power draw as it starts to add in red, depending on how your software tells the strip to be white. There is also the possibility that it uses the RG and B diodes as well, cancelling out any efficiency gains. So, now the final issue for me to overcome here was working out why the voltage drop was still an issue, even after upgrading the power supply and the thickness of cable to the end of the strip. And it turned out that these connectors were not giving a solid enough connection, and either causing lots of noise or a reduction in the current transferred to the end section of the strip, or both. So my final optimization was to try and unstick the smallest amount of strip possible in order to sit on the stairs soldering these connections instead. And since doing that, the entire thing has worked flawlessly on any colour or brightness. I wish I had it at the time, but I have since acquired a handheld soldering iron, and I'll put a link to that on my website too. And I'll throw in a quick tip here because I don't think it can be said enough. Whenever you're cutting an LED strip, you always need to find a cut point, which are usually clearly marked on the strip, but you don't have to cut the centre where the line is. If you can, always try and cut the end of the copper pad to give yourself the largest contact patch for the connector or solder to attach to. Now, this will mean that if you go to use the offcut of LED strip that you've cut off, you will be sacrificing an LED in the process when you cut the other pad, but it's well worth it for the difference in result. So to summarise my experience with this install, it should have actually been quite easy to get the setup I wanted. If I'd have had a little more patience to wait until I had proper power supplies, the correct cable, and soldered the critical connections, it would have been a very simple install. Pop the power supply where it needed to be, run a suitable power cable to the strip, cleanly connect and configure the controller, and stick it all in place. But as usual, I took the long way there, so you don't have to. Anyway, I hope you liked this video, and thank you so much for watching. And more than ever, for reasons I won't go into, if you're able to support the channel in any way, please do so by buying our LED controllers or any other product I recommend using the links over on my website. Or subscribe to me on Patreon, YouTube, TikTok, or just buy me a one-off coffee and I will be eternally grateful. Thank you again for watching, and remember, home is where the smart is.